Welcome to solverfy.
We're given a recurrence relation and an initial condition, and we're asked to use generating functions to solve this recurrence relation with initial condition. The recurrence relation is a sub k equals 3ak minus 1 plus 2, where a0 is equal to 1. To use generating functions, suppose that g of x is the generating function for the sequence ak. This means that g of x is going to be equal to the sum from k equals 0 to infinity of ak x to the k. Well, in this case, we have that this is equal to a0 plus the sum from k equals 1 to infinity of ak x to the k. And by the recurrence relation, we have that this is equal to a0 plus sum from k equals 1 to infinity of ak is equal to 3ak minus 1 plus 2 times x to the k, and this is equal to a0 plus 3 times the sum from k equals 1 to infinity of ak minus 1 x to the k plus 2 times sum from k equals 1 to infinity of x to the k. We have that this is equal to a0 plus 3 times the sum from k equals 1 to infinity, or k equals 0 to infinity, for making the substitution k minus 1 for k. So we get ak to x to the k plus 1 plus 2 times, and here we have the sum from, I'll change this to k equals 0 to infinity of x to the k. So we've added 2 in effect. We still need to subtract 2 to keep balance. This is equal to a0 plus 3 times x times the sum from k equals 0 to infinity of ak x to the k plus 2 times, and this reduces to 1 over 1 minus x minus 2. This is equal to a0 plus 3x times g of x plus 2 over 1 minus x minus 2. So now we have g of x on both sides of our equation. So to solve this, we want to get g of x on one side, so I'll subtract 3x g of x. So I get 1 minus 3x g of x is equal to a0 plus 2 over 1 minus x minus 2. And so we have that g of x is equal to a0 plus 2 over 1 minus x minus 2 divided by 1 minus 3x. And therefore, if we take a0 to be 1, we have that g of x is equal to
This is going to be 1 minus 2 is negative 1, so 2 over 1 minus x minus 1 over 1 minus 3x. This is going to be equal to 2 minus 1 minus x. 2 minus 1 is 1, and then minus x is 1 plus x over 1 minus x. Maybe the simplest way is simply to multiply top and bottom by 1 minus x. And so we obtain 1 plus x over 1 minus 3x times 1 minus x. And to write this in a form so that we can determine the coefficients of the power series, we'll want to use partial fraction decomposition. So we have that 1 plus x over 1 minus 3x times 1 minus x is equal to some coefficient a over 1 minus 3x plus some coefficient b over 1 minus x. And if you multiply both sides by 1 minus 3x 1 minus x, we get 1 plus x is equal to a times 1 minus x plus b times 1 minus 3x. And this is equal to a plus b and plus negative a minus 3b x. And setting the coefficients of like terms equal, we have that 1 is equal to a plus b, and 1 is equal to a negative a minus 3b. And adding these two equations together, we get 2 is equal to negative 2b, so that b is equal to negative 1, and it follows that the back substitution, a is equal to 1 minus b, which is negative 1, or 2. And so we have that the partial fraction decomposition gives us that g of x is going to be equal to 2 over 1 minus 3x minus 1 over 1 minus x. And now we use some theorems about power series. This is equal to 2 times the sum from k equals 0 to infinity of 3x to the k plus, not plus, but a minus, the sum from k equals 0 to infinity of x to the k. And combining this into one sum, we have this is the sum from k equals 0 to infinity of 2 times 3 to the k minus 1 x to the k. And we have that since this is the same as g of x, which is the sum from k equals 0 to infinity, these two power series are equal. It follows that the coefficients are equal. And so we have that ak is equal to 2 times 3 to the k minus 1.